Welcome to Enabling Agility with Data Governance on AWS. Very excited to talk to you about data governance. I don't think I've said that before, but today it's going to be a good talk between myself and Shihas from Prudential. So thank you. I run our Lake Formation product as well as the Glue Data Catalog here at AWS. I've been with Amazon for about 8 years. I was running our analytics practice and professional services for most of that time. We're helping customers build data lakes, help them migrate their data platforms to AWS and become data-driven. So let's go see what we're going to talk about today. So the first thing we're going to talk about is how does data governance help you become data-driven? The second thing we're going to talk about is data governance patterns within AWS analytic services. And then Prudential Financial will come up and talk about their data journey and how they actually did it for real versus me just talking about some PowerPoint examples. So let's start first with data-driven themes we hear from customers. And I like to start with this about data governance because it's so critical hand in hand. The first thing you want to learn is that the top part of it and the bottom part of it are coupled in a way, but the top part is more about business context and the bottom part is more about people, process, technology. So what customers tell us they want to be data-driven, they struggle with a few areas, and these are consistent themes across many customers we talked to. The first thing is understanding what great looks like. And this isn't about just building a roadmap or understanding what I'm going to do next. It's actually what is great and what will delight your customer. At Amazon, we talk about working backwards or writing PRFAQs to go through that process and really articulate what is great. And that's your first start in your journey with data governance as well, and we'll tie these together in a moment. Once you know what's great looks like, you prioritize those use cases and you create sponsorship just like you would with any other initiative. On the bottom row is when it fits into data governance, as you start building these use cases to solve business problems, you integrate things like data-driven culture, data literacy programs, understanding data definitions. You focus on gaps of skills. Maybe you need to introduce a new tool that users need to understand. And the last thing is security is number one. If we're going to drive business agility with data governance, we need to make sure your data is protected, secure, compliance controls are built, because your customers and users of data need to make decisions at the speed of their business. And without protecting data at that same speed, you could create additional business risk. So some other areas that we've seen other publications talk about is, for example, Forbes gave some statistics. 85% of businesses want to be data-driven, but yet 37% have really struggled with it. And why have they struggled? And you see some quotes around from IDC. Data governance is a core struggling area for becoming data-driven. So it's no longer optional, is what IDC says, for enterprise organization to get the most value of their data to make decisions. They really need to treat data as an asset. The second part is organizations lack knowledge of efficient and effective data governance activities. And 30% of the time is wasted doing data governance things, data definitions, data management, data security. And these are areas you can definitely automate that we're going to talk to in a few minutes. So let's put some definition around this. This is how we define data governance here at Amazon. There are thousands of definitions of data governance. So I'd love to hear yours as well. But this is how we define it. So data governance is the collection of policies, processes, and systems that organizations use to ensure that quality and appropriate handling of their data throughout its life cycle for the purpose of generating business value. And to me, what really sticks out the most is a few things, one of which is the last line, generating business value. We do not want to do any work in data governance without a business value associated with it. Let's go a little bit deeper into that. So data governance starts with business. The first thing you want to do is tie it to your business strategy. And I'll tell a bit of a story. So I'd say like 15 years ago, I got very excited. I was managing a customer data system. It was probably pre-Salesforce at the time. And I'm like, our data is really bad. I need a data quality tool. And I went up to my management. I'm like, we're going to go buy a data quality tool. It's going to be X hundreds of thousands of dollars. We're going to solve our customer data problem. It wasn't funded. And I didn't know what to do. I'm like, I can't understand why this wasn't funded. And I wasn't really thinking about it. We didn't have a customer analytics problem to solve at the time. You'd think that most customers had that problem, but We didn't have that. We knew our customers, our business. It wasn't the biggest company at the time I was dealing with. Our business people knew our customers really, really well. And they weren't going to invest in a data quality tool. So what's important here is understand your business challenges and start your data governance journey with that. Once you know those business challenges, you have data consumers. Data consumers are those that need to use data to make decisions. So those are the folks that will understand what data they're going to ask for, what data they're going to look for, and what metrics they need to solve business problems. They're going to choose to inform data producers. So data producers could be data owners, system owners, data lake admins. Here is the data I need to do to solve my problem that ties to the business strategy. How can you help me? And that's where data governance really kicks in. So this is our data governance, I guess, bracelet charm slide that we talked through. And there's two areas. There's the top portion of the slide and the bottom portion of the slide. So we've been talking about schema on read for a while here in this industry. Schema on read is an interesting concept because you definitely want to just put the data in and people can get value really quickly. But does that really help a data user make decisions faster? So what you want to do here is the top part, as a data consumer is asking a data producer for more information, those producers should ingest that data quickly. They need to automate classification, automate data profiling, automate data quality, and secure and encrypt that data before they give access. And that brings that real understanding of what that data is so that users can quickly be provided access to that information. For example, data classification. What if your data had PII and the producer of data didn't really know what their role is in the organization to protect compliance controls or GDPR? So automate data classification on the way in. The last thing is catalog. So before giving access to data, you want to catalog your information. Bring that technical and business context to your data, and then give users access to that to make decisions. I was at a talk at Amazon a couple years now, and they talked a bit about the value of data. And they talked a lot about schema on read and how this fits in. But what you want to do is maximize and get data in the hands of users as fast as possible in a secure and compliant way so that they can make decisions at the speed of their business. So we'll talk a bit about automating the top part of the slide. The bottom part of the slide is once data is in the hand of consumers, they can manage that data. They can create new data sets. They can then become producers on their own. So if you think about a consumer, in that point in time, they might be using data, accessing, querying, making decisions. They don't just make a decision and it goes away. They want to create something new to share with their executives, share with their business partners. That's where they actually become a producer, and they're going to be data curating, data integration, building lineage, securing that data, and continuing that life cycle of data throughout. So how do AWS services help? So I'm going to talk about three main challenges here. The first one is how do we automate data integration, classification, and data quality on the way into your data lake. The second area is how do we catalog and make that data more usable. And the third area is how do we automate sharing so that users can get access to the data they need at the right time and as fast as possible. So let's go a bit deeper into automating ingestion. Lastly, you want to make sure that they can publish those data sets back through that same ingestion pipeline. So automating data governance on ingestion is a hard problem. Let's talk about why it's a hard problem. The first thing is data comes in various forms. It comes streaming, it comes in batch, it comes in CDC, it comes from SaaS applications, it comes from different file formats, and it's variable over time. So automating that process is hard, but can be done over time by building a set of patterns, and we'll talk about an example pattern in a moment. The second thing is automation with CI/CD pipelines, so to make sure that your enterprise standards are built into that automation of ingestion, so when a new pattern comes in, your CI/CD pipelines can adapt. And you want to handle it for many data sources, RDBMS, files, streams, SaaS applications. The second challenge you want to handle when you're automating data, or data ingestion, is handling inconsistent performance, reliability, and quality. So as part of these reusable ingestion frameworks that you might build at your customer sites, is you want to understand how data is stored. You want to handle inconsistent data formats. over time, as you see more patterns across all of your systems, you'll actually understand that those patterns happen over and over again across variable systems. You can build a library of data quality rules, a library of data profiling statistics. And the last thing is you want to standardize your data quality so that users in one system understand the data quality rules that were applied. So let's say you have multiple SAP instances. There might be the same data quality rule can apply to different instances, so you get the consistent data use on the way in. And the last thing is bringing in compliance and regulation. So as you're monitoring your data quality, you're running data profiling, you look at the data, you inspect the data, and you use things like machine learning, such as Glue as PII detection. Then there's Macy, for example. Comprehend can do some PHI detection as well. How do you automate that as part of a pipeline and then classify that data on the way in and carry it through your environment? So let's talk through a real example that covers the ingestion piece of it. So I'm going to cover data classification, data profiling, data quality, securing, catalog, and this can all be done with CI/CD. I picked a different icon here for the AWS Data Ops Development Kit, which is an open source project built on top of the CDK for cloud for building data pipelines faster. And that can help you automate a pattern such as this. So what you see here is the pattern on the left is Salesforce, and on the right you have an ingestion pattern for a SaaS application. So you can use a product like AppFlow. AppFlow can push that data to S3, and that's where you can run your data quality rules as it lands in S3 and as you move it to curated. As it lands, we're going to talk a bit about glue crawlers and how they remove the heavy lifting. So glue crawlers will inspect your data. You can build custom classification rules within your glue crawlers to manage your schema. You populate your data catalog, and you propagate that to Lake Formation to manage access controls. This is just a standard pipeline, and Shias will talk in more detail of what happens in real world. Obviously, it's not as simple as this, but this is just an example of what you build. So you build this once, you apply it for Salesforce, and as other databases come in, rinse and repeat. Then you end up just replacing that first line that goes into the box over time. So let's talk about the second area. The second area is cataloging data and making that data more usable. You want to make sure that data is findable, searchable, accessible, so people can look at it, understand it, request access to it, all from a single place. So how do our services help with that? I'm going to talk a bit about crawlers, for example. There's glue crawlers that eliminate the heavy lifting on managing schema. So now we've ingested that data. We have data quality built into it. We have technical catalog. This is really where we want to extract that information out of your data and start populating and enriching your catalog over time. And you can start with your technical catalog, and we'll talk about the business catalog in a moment. So the first thing is crawlers discover new data sets and extract schema definitions. I know what you're saying. Yes, I can do this in code. Yes, I can do this in APIs. Sure. There are many ways to handle schema definitions. But what you're doing here is you're reducing that heavy lifting so programmers don't have to worry about catalog management. And you just put it on the crawler, and you can let us know if our crawlers aren't working well enough for you, and we can fix it and improve it. Crawlers cover a wide array of sources from S3, for example, DynamoDB, MongoDB, all of our RDS, Aurora, for example. Recently, we announced Snowflake last week, so we can now crawl Snowflake and provide that schema available for you so that you can start understanding what data is coming into Snowflake over time and manage that incrementally. Then there's additional catalogs. So Glue catalog, you can add catalogs that aren't covered by crawlers. So there is a bit of a difference there. Things like CloudTrail, Kafka, for example, with schema registry. The next thing Glue catalog do is they use a built-in classifier. So you can do popular data things such as PII identification. You can write your own custom classifiers with Grok, and that allows you to enrich your catalog with the technical metadata about what that information is, so you can better protect that in the long run. And by adding those patterns over time, you start building up a library of them. So going back to our business case, let's say our business case is customer analytics, and I need to identify PII, you can then apply that first PII rule to other data sets that might have customer data in it and leverage that over time. The last thing is crawlers run on demand. They can run on S3 events now and incrementally. So you can just have them run on S3 events, run them incrementally, and all you have to do is watch monitoring alarms if they fail for some odd reason. And the last thing is a couple new releases is AppFlow, for example. AppFlow is not a crawler feature, but a catalog feature. You can now populate your data directly from AppFlow within features within AppFlow as you're pulling data in from their connectors. The next area I'm super excited to talk about is what Adam talked about this morning, which is Amazon Data Zone. So in the catalog space, we talked about technical catalog, but what about business catalog here? So Amazon Data Zone is a new service that enables customers to discover and share data across your organizational boundaries, lines of businesses, with built-in governance, access controls, and that removes all of the heavy lifting when it comes to making data available to everyone in your organization. It improves the operational efficiency of managing data, managing access controls, so that data teams focus on working with data and not worrying about who has access to what data when. It's built on top of Lake Formation, so you can actually extract and present that information around who has access to what data. So you have centralized logging, monitoring, and it provides you that single point without having to worry about AWS analytics services. So super excited about this launch today. It comes with 4 free key features as an organizational-wide business data catalog, and you make that available for the context of all your users to find what data you have. The second area is it has governance and access controls with built-in workflows for that example we talked about earlier. So data consumers find their data within a single user interface. They request access right from that interface. And then that system has that workflow for giving those consumers access to that data, right, so they can use the tools within the simplified analytics portal that they've created with you. Out of the box, it works directly with Redshift, Athena, for example, and other services that you'll learn about more over the upcoming week. The last thing is there's a data portal for an integrated data experience for users to promote their data exploration and drive innovation throughout your organization. So let's go to the last area, which is automating sharing of data. So we've done a couple things now. We ingested our data, we know the quality, we know the technical metadata, we know the classification, we've added the business context. Now we need to actually share that information and share it at scale. Customers are adopting many patterns. Some customers I talk to all the time might start with a single account, central data lake. That might work for them for the short term or even the long term. Over time, they might move to a hub and spoke architecture where you have a central data lake, for example, and then you start adding extensible consumers to that information. Then there's customers obviously adopting data mesh. There are a couple talks on data mesh this week. I recommend you see them. Super exciting, cutting edge about how customers are building interoperable data sets and leveraging AWS infrastructure to both provide that flexibility but also protect that data at the same time. And the last pattern we're seeing is business-to-business data sharing. Obviously, we've got Amazon Data Exchange, but also customers are learning different ways to share data. And we'll talk about that in a moment. So how do we do this? The first thing we recommend is looking at the Lake Formation permissions model. So Lake Formation provides database-style fine-grained permissions on your resources. Your resources are database, are tables and columns, for example. You scale your permissions model through Lake Formation tag-based access controls. So we'll talk about tag-based access controls in the next slide. But what you're doing is moving from what we say resource-based access controls, managing your tables based on your user community, to tags, which you're focused more of your energy on like what data sets they are and how do I scale giving people access to that data set based on what they are and what classification rules they provide. It provides unified Amazon S3 permissions. It's integrated with services and tools, and also third parties are integrating with Lake Formation as well, and easy to audit permissions for access. So let's go a bit deeper into tag-based access controls. So imagine you have hundreds of databases and thousands of tables and tens of thousands of users. That becomes an awfully terrible matrix of access control permissioning that you need to manage for role-based access controls. So this is why we introduced tag-based access controls. And if you are using one of our original ways, when we launched Lake Formation, it didn't launch with tag-based access controls. If you are not using it today and you're running into scaling challenges, we definitely recommend talking to your SAs, talking to us about how you can think about moving your access control permissions to tags. The first thing you want to do is define your tag ontology. So your tag ontology could be things like organizational structure or classification rules. And the next thing you do is you apply those tags to catalog resources, databases, tables. The higher you apply the tag, the more predominant the access is given, right? So you could provide it at the database level, for example. They're hierarchical in nature, and if there are conflicts, the system resolves those conflicts. The last thing is you create those policies on those Lake Formation tags for IAM users and roles and Active Directory users and groups using SAML assertions. So that's how you scale your access permission. So let's put this in context to your architecture, right? So we're seeing customers adopt a few different patterns here. On the top left, you have your business data catalog section. I'll simplify it because these systems do a lot more than business data catalog, so please don't take this too seriously. There's Amazon Data Zone, which does way more than business data catalog, but I just put it in a box. So entry point, I find my business data, and I need to request access. The next area is third-party tools. You could be using third-party tools to find data, request access, and understand those data sets. Or there's open source solutions like data.all, for example, that you could leverage. So there's a few different options we're seeing customers do today. The next thing you want to do is, regardless of the option you're doing, so Data Zone works out of the box, but if you're working with a third party, work with them. I've seen many examples. I've actually blogged about one with Informatica, about how to automate workflows within Informatica to drive your access control permissions down to your data catalog. Most of the ISVs can do those workflow processes and push those access permissions down. They can also, a lot of them can also read up your Glue data catalog to understand your classification rules. When you do that, you then push down and make sure that you're using Lake Formation for your catalog, Glue data catalog for your catalog, Lake Formation for your permission model, your policy control, and access down to your data domains. It could be your S3 data lake or Redshift for that example. So that way, when your users are coming in through various engines, whether or not it's Amazon Athena or Spark on EMR, it's enforcing those policies consistently on how they requested access from their business context. It provides that end-to-end experience. So with that, I'm actually gonna, I have one more slide. So key takeaways, and I'll hand it over to Shihas. So key takeaways on enabling agility with data governance on AWS is automate ingestion. Build up those patterns as part of your business strategy and understand how you could automate compliance controls, standard data quality rules, so that data engineers can move at the speed of your business. The second thing is automate classifying, cataloging, and profiling your data on the way in, so that your catalog understands the technical information and your business catalog starts to understand what is the classification rules you need to apply when you're giving people access. The third area is automate the management through tag-based access controls and make sure you can scale through your enterprise so that your data is protected throughout its life cycle and you're not consistently managing permissions over time. And the last thing is automate data sharing through one interface, whether or not it's through Amazon Data Zone or ISV partners or open source solutions you build on your own. Automate that experience so a user comes in, finds the data, requests access from a single user interface, and that they know what they're getting and they know their data is protected on the way in. So with that, I'm going to hand it over to Shihas to tell his story. Thank you. Here.
I'm good. Oh, yes. Can you all hear me well? Right. I'm Shihas Wamanjur from Prudential Financial. My team made a request for me to open this 30-minute presentation in their words. Here goes. Over the next 30 minutes, you will be introduced to the next generation of data platforms, a fully self-creating, self-organizing, and self-managing platform we call the Autogenic Data Platform. Folks in today's audience are among the first outside of Prudential to learn of this innovation. This is the future of data platforms, and the future has already arrived at Prudential. Harpreet and Zain from the data platform team are witness for me having said this at reInvent. A little bit of background. I'm from Prudential Financial Services. Prudential is a global leader in financial services. We serve both institutional as well as individual customers. We are in over 50 countries, 50 million customers, 40,000 employees. Let's focus on the 40,000 employees for the rest of the conversation. Me, I'm situated within the Prudential Chief Data Office. I'm the product owner for enterprise data platforms. The mission of the data platform is a big and bold one. Number one on our mission statement is to democratize data, to increase the value creator base within Prudential. That's the number one thing. Other pieces, increase velocity of data innovation, reduce costs, reduce risk, so on and so forth. Now, who does this data platform serve? At Prudential, in the multiple lines of business, both domestic and overseas, we have a large community of technical and non-technical users. Technical users are data scientists, data engineers, data analysts, data stewards, business intelligence professionals, machine learning engineers, so on. You get the drift. Non-technical users, line of business managers, business initiative owners, executive. What do they do with data? They want to exploit data to create business value. What are the common challenges? On the slide is some of the common challenges. These challenges all lead to long time to value. First of them, hard to locate data. Why is this hard? Why is this such a challenging problem? Our companies are growing continually. Data is also growing continually, exponentially. So we have a large number of systems, and knowledge about these systems is usually tribal. That basically means the owner of the system is the one that you tap on the shoulder to dig out information about this data. Time-consuming process. Now when you start to multiply the number of systems that you have to deal with. Second, long time to access. Since there are a large number of systems, you got to go through governance hoops. You got to go from system 1, 2, 3, 4, 5, bring it to another system, another set of ACLs to deal with. Third, lots and lots of human engineering. Since we have so many systems in the source side, and the technology space is constantly, rapidly changing, you have a lot of technology requirements in terms of understanding this. You got to be a Superman engineer to try and extract data from all of these systems, bring it to another system. Complex governance. I talked to this about the number of systems and how governance become complex. And finally, there's a lot of tedious and repetitive work before you actually start to do what you really want to do, right? So when I started this journey of building out this enterprise data platform, I went on a listening tour. 2 eyes, 2 ears, 1 mouth, keep the mouth shut kind of tour. So I was listening to what they really wanted. Here are the desired experiences. 1, they said, can you make it simple for me to discover data within this entire enterprise architecture? Wherever data lies, really don't care. Is it possible for you to deliver to me an e-commerce-like experience? I just want to shop for data products. No, this is not a shoe or a watch. It's a data table. It's a data view, a file. I want to shop for it. Second, I really don't care what these systems that house the data are in. I don't want to be bothered about pulling data from system X to system Y. Data shipping is not a heroic job. There's no glamour in it anymore. It's very hard to convince people to do that. So this no ETL is a no-brainer. That's second. Third, why can't you build me a system where you optimize my time as a data value creator so I can focus on actual value creation rather than spending 90% of my time bringing data over from arcane systems, cleaning it, massaging it, and getting it ready so that I can create value. Finally, if this data is in a system that I can get access to, how do you make it accessible to me through a few mouse clicks? Those are the challenges. This is from a very initial draft of our concept. I said, I hear you. So what you're really asking for is the genesis of an autogenic data platform, a platform that creates itself. And you, the value creator, are the master, not the platform engineering team, not a data engineering team, but you have the keys to this entire ecosystem. How would it work? The autogenic data platform has to catalog and discover at scale all the data assets that you have within the enterprise. Right? It's got to make it available in a marketplace. That's number one. Once it is in a marketplace, what do you do next? You use an order fulfillment request system. So you press those buttons, make sure the data goes over to a data and analytics platform where you can exploit it. Number three, you do not want to do manual data governance, manual data engineering, none of those things. You expect the system to take care of it for you. So you bring the data through automated data governance, data privacy, through a highly automated data processing engine into a zone. Finally, give me another set of order fulfillment requests in the same marketplace so I can get access to my data. This was the ask. At this point, I had a few important questions that I need to answer. Looking at this end state vision, I had to decide, number one, which partner would I choose? There's a series of services that you need, intricate engineering that you need to put together and then hide it all away. That's the goal. Number two, what style of architecture would I use? What method of development would I use? For the first, it became quite clear to me, of all the cloud service providers, the most mature one with these services was AWS. So we made the selection to go with AWS. Second, for the partner, we chose AWS Professional Services. They were closest to the technology, and this was a design that was not trivial. Finally, we chose agile as the method of development. I told my team that we would deploy the initial version of the autogenic data platform into production within 3 months, from which time onward, every release would be a sprint, which would be 2 weeks. And the reason we did this is we always found that building with the expectation of someone coming to use it never works in practice. So that's the method that we chose. Fast forward 9 months. What do we have? We have a completely automated, I would call it hyper-automated system. We have a marketplace. We use a front-end technology for the marketplace, which I'm glad to see Jason's presentation that Amazon's done some wonderful work, which we will reverse engineer. We have some front-end technologies for now which take the place of the marketplace, which does the order fulfillment. We have a lakehouse construct, a construct of bringing data from whatever pattern, whether it is files, whether it's JDBC, whether it is batch, streaming, all the fancy bells and whistles that people usually want in a data platform, we have all of that. But incrementally, we built that over. Now, what we then went forward and said, the true value is in shifting engineering right. So we then said, okay, let's look at the key aspects of any data and analytics platform. Let's do things like data quality. Let's do things like data standardization, PII detection, change data capture and management, all within an automated environment that no human being has to write code for. That was the goal. So over a period of 12 months, we've achieved this goal. We're not at the completion of the journey. The journey is still a long one. But the usage has been significant. Right from month 3, we've been able to onboard different data journey teams to the platform, and now we use a process of user-generated demand to build any new features. Now, one would think that this requires an army of engineers, and Prudential is a global giant. You would have access to an army of engineers to build this. Not true. Small core team. They're sitting in the first row. We've got Zain, Harpreet, Samer. These are the cloud and data engineers, along with ProServe. Jason was part of the original ProServe team that helped build this out. Dozen or so people, under a dozen, including management, was all it took. Great effort from the collective at Prudential. They provided all the collective muscle to make this happen because this was a common shared goal. In terms of architecture, let's get down into a level of detail that is necessary for this conversation, and it ties closely to what AWS and Jason have been talking to in the previous presentation. Number one, here's a representation of sources, logical representation, and this is what you are likely to see in your own enterprises. It has everything, data center-based databases, file systems, SaaS applications like Salesforce and ServiceNow, APIs, basically source of first-party, second-party, third-party data, wherever it may be. The second part of this standard architecture is the ingestion service layer. This is where incrementally the autogenic data platform has features that allow for different types of sources to be handled differently but intelligently. So you start with flat file data transfers. Okay, here's AWS Data Sync. But here's the difference. Nobody needs to know how AWS Data Sync works. That's coded into the automation. You provide the order that says, I am a file source. The autogenic data platform detects that a file source is best suited for a data sync transfer program. You are a JDBC source, so I'm going to use Glue JDBC. Oh, you are Salesforce. I'm going to use AppFlow. So that's the detection mechanism that's built into the programming. Now, as you go rightward, you'll start to see persistent layers in the architecture come through. Persistent layers are both a lake as well as a house. Now, up to this point, what you have to imagine is there is no human being writing any of this code, not for infrastructure, not for the services, not for the pipelines, not for the orchestration. All happening by the application. The application has taken control. So it is self-creating. So what happens next is data is now moved through this persistent layer from raw to standardized, applying the data quality rules, the governance rules. Change data management and change data capture is embedded within this pipeline. And then the data is now available to the curator. But at this time, from a governance standpoint, one would think, hey, is this data all accessible to people? No. The process has decoupled access provisioning from data movement. None of this data is actually accessible. Now comes the central governance, which is what Lake Formation is for. We centralize governance to all the assets through Lake Formation, one single point of access provisioning to this entire ecosystem. Finally, we have all kinds of consumption patterns that get access through this Lake Formation central governance layer to this entire lake house. Now, what I didn't talk is just as important as what I just said. What we have done thus far is hyper-automate the journey to a standardized layer. The journey of data exploitation does not end there. It begins there. But now is the value creation exercise. Now you have these highly skilled resources, the talented folks who can use this ecosystem to refine the data. Now, I have another innovation project in the works, which is trying to machine this curation as well, so that regular refinement to create a data product is the focus of my data journey teams today. And this architecture has allowed them to do so. Let's unpack this a little bit more. Here's a sample user onboarding experience. Right? This is how users onboard data to our platform today. Here's a data athlete, technical user, non-technical user. As long as you can use the browser, you're welcome. You go scan this marketplace. It looks like Amazon.com or whatever your favorite e-commerce site is. Right? You get a collective that is a bunch of objects or a single object. It's your choice. You then say, I want this object to be refreshed at a given frequency. You then set submit order. Internally, the metadata generated by your order is the heart of this intelligent platform. This uses all the metadata that's been collected so far to provide instructions to this auto-generating system. Now, the auto-generation actually creates the infrastructure as code. That's the first order of business for it. If that is an order that is coming in for the first time, all the infrastructure necessary is created dynamically. Because the metadata, the manifest, contains the information that is sufficient for you to have a targeted creation of both infrastructure and pipeline and orchestration. Post that, it then identifies the necessary elements to actually execute on this. So as an example, when I process an order for a database, for a file system to be transported, the first time creation of the infrastructure takes place. Subsequent runs of that infrastructure pipeline are now available as an order fulfillment request that this entire automation takes care of. That's how this whole thing works. So in a sense, what we've now been able to do is to say, for the foreseeable future, run this kind of pipeline, moving this kind of data from these systems to a secondary system for data and analytics. And the system is responsible for the orchestration, the constant redelivery, the remediation, the notification. All of that is now built into the system with embedded governance, embedded data quality, embedded everything. That's what hyper-automation is all about. Now, if you take an example of a user experience for access, similar, nothing much different. The toys are different. What we use as AWS services are different. But the experience for the user is the same. He doesn't need to see this. Like I said, the heroics belong to the data engineering team. Vendors will provide all the necessary services. It's up to us as users of those services to determine the experiences that we deliver. The experiences that we choose to deliver as a platform team is an abstracted experience. We try to figure out, why is it necessary that you have to do something? The answer usually is, you don't need to. So if the answer is you don't need to, we hide it behind a browser. So you can focus on the actual value add. Similar experiences you will find in data warehouses. The reason why I have this extra slide is to tell you that no matter what kind of infrastructure aspect that you have underneath, today I have a data lake, a data warehouses, tomorrow I have a graph database. Tomorrow I have another kind of repository. Doesn't really matter. The method is the same, the ideas are the same, the way you do it is exactly the same. Now, key lessons learned. This is from our journey over the last 9 months. It's going to differ from journey to journey. Super important to have a clear vision of end state. And this is important because there's too many shiny tools in the market, too many distractions. You're going to hear about, do this with domain-driven design, do this with application-oriented design. Yeah, those are important, relevant topics. Take away from the real focus, which is you stay focused on your users. Who are they? In this case, they're internal. We, according to our CEO, 2 classifications of employees. Colleagues who help customers directly, colleagues who help customers. My customer is internal. The product that they build will be used by external customers. I've got to stay focused on them. So I've got to do everything that helps them do things at a faster clip, at a lower energy expenditure level. That's my focus. So stay focused on your users. It's super easy to get lost in this jungle of innovation that every vendor is out there peddling. Second, automate governance at every step. You will hear that governance is a beast, hard to automate. Tackle that head on. Ask what exactly is hard to automate. Data quality routines? No. Configurable. You apply a rule set. What else is hard to? Data ownership? Nope. Embedded at an object level like we have. Every asset within our ecosystem, every table has a data owner embedded in it. What does that do? Helps you approve things quickly. Helps you understand ownership models quickly. So question anything that takes away from hyperautomation. Third, this is very important as well. You need to build a small, core talented team. They need to do two things. Number one, they're responsible for feature development. This feature development is driven by user demand. You don't try to build for the future without knowing your actual user demand. So you got to be super close to the user. At the same time, while they build these shiny new features, it's also super important that they support users who are currently using the platform. So you got to have two parts to the team. One that keeps the light on, keeps remediating, keeps fixing. The other is to build out the new feature. The other tried and tested value in trying, value in failing. There's a lot of lip service in enterprises about fail fast, be brave. But when it comes to impacting your timelines, your deliveries, it's not looked upon kindly. In our experiences, there is no escaping that fact. You simply accept it. This is the cost of doing business. You're going to try with numerous AWS services or other cloud services for that matter. You're going to try combination of things. There are certain things that you don't want to invent. You just don't want to invent authentication. You don't want to invent authorization. You don't want to invent encryption. Lots of things you want to take services that have already been created. But how you glue them together, you'll have to test it yourself. Now, the reason why I bring this forward is, I posit that you have to create an engineering team for yourself. You have to treat this as an application. Historically, data platforms have not been treated as applications. They usually have been approached as a data product or a data platform product by itself with some integrations. The change here is we talk about an autogenic data platform being an application, and here's a product owner, and here's a development team for that application alone. No different than any software product. So this is a software engineering team internally servicing it for the enterprise customers. There is a super important construct to remember. Now, in terms of outcomes, everybody loves outcomes. And everybody has these OKRs that measure the value of what you have done. For us, it's quite clear that this is a winner. The increased talent pool, what does that talk to? That talks to now us not having this class system. Oh, you don't know AWS Glue, do you? You can't participate in our ecosystem. No, we don't have that conversation anymore. You can use a browser, you're welcome. What more do you need in order to be successful? You need that browser to have SQL embedded, a query engine. Okay, the platform team's here to support you. You need Excel embedded within the same data portal? So be it. We deliver it to you. We don't levy a tax, a learning tax. Historically, platforms which have not been created through this vision apply these taxes. There's a regime of taxes everywhere. You pay repeat taxes every day in your work life. The mission of this platform is to eliminate those taxes. Second, time savings. Our original goal was to shift right as much of human engineering as possible. Current state of the platform has shifted. The first point where human engineering starts to be involved is when you have to curate or refine the data. So you've cut the taxes all the way to that standard layer of your lakehouse architecture through this autogenic data platform. Third, data access. That's been cut from days to minutes now. It's within the application. It's within the same data marketplace. It's an application that is governed. It is auditable. It tells you who granted access to who and for what data. All of that information is present within the tool itself. Cost savings. When you release such an application to the enterprise, you decrease the appetite for building bespoke data solutions. Because now you have to compare it against something that has so many features and works so well. Success. Success is super important for that reason, that it decreases the appetite for folks to try this on their own. There's no harm in trying things on their own, but then you would see the engineering that is necessary to create a holistic, integrated system. That's super important to realize. Now, in terms of governance, this was a governance topic. So I want to talk to a certain aspect of governance as well. Trust in data gets better when human beings don't finger the data. How far right can you move that? That's the question. How can you report on the hops of data that's taking through an automation? How much of this quality stuff can you move towards the left of the equation, which is the source of data? And how much of it can be subject to the automation? So it improves trust in data because you have not touched the data up to a certain aspect. Now you can also focus your energies as a data governance organization on the actual place where data is changed, which is the refinement zones. If our innovation is successful, we'll move it even more to the right. But for now, there is a narrow focused area, which is either on the left side of the entire architecture, which is in the source, or on the right side, which is in the curation zones, where you can now focus on. Your focus is not spread. And lastly, because of the popularity of the platform, we are seeing reduced data sprawl. We are seeing more and more multi-tenant teams, data journey teams come and use the platform. It's also integrating our data. So it's subjective whether that was one of the primary views, because we still live in a very federated business model. But the goal for us is to reduce the data silos. I know I've said a lot. For additional thinking around this topic, I also published a Medium and LinkedIn article under the header Autogenic Data Platforms. Feel free to hit me up my social media handle at LinkedIn. Happy to collaborate. At this point, I think Jason and me are happy to take questions.
2 more slides. I have 2 more slides.
Oh, sure.
So just 2 more slides. How do we get started? There's 3 programs that AWS offers to help you get started. The first one is if you want to build a data strategy, we have our data-driven everything program. Feel free to reach out to your SAs or your account team to understand more about that program. The second one is Data Labs, is have that strategy and help executing it. That would be our Data Lab team. And the third one is if you need help with implementation, there's obviously ProServe and our great partner community as well. So those are our first ways to help you get started with data governance. We do have a new workshop that are both our D2E, our data-driven everything team, and our ProServe team can help you execute. It helps you understand where you're at with data governance. So please reach out to your account team to understand where you're at in your journey with data governance, and they're happy to help you with that. And the last thing is getting started. Think big. Use that discovery workshop and data governance. Use things like data-driven everything. You want to think big, but you want to start small. How does this apply to your business strategy? How do you use tools such as Data Labs and ProServe through POCs? And then how do you scale fast through partners and ProServe? So thank you. We're happy to take a couple questions. We have a few minutes if people have questions.